Today I want us to look at a topic under trigonometry, which is the trig ratios or the trigonometric ratios of angles 30, 45 and 60 degrees. So we are going to take them one after the other. Okay, so but before we look at that, please don't forget to subscribe, like and share this channel. Okay, now we are going to use an equilateral triangle to look at this. So let me draw my equilateral triangle. So the three sides equal means that this is 60, this is also 60, and then this is also 60. Okay, now let me try to divide this by 2. So it means that this side becomes 30 degrees. Okay, now since the three sides are equal, let me say that this side is 2, and then 1, 1. That is 2 units. So 2 units each. Okay. Now I want us to look at this. If this side is 2 and this side is 1, that is from here. So let me call it triangle ABC. Okay. So and then this is D. So triangle ABD. We are only considering triangle ABD. Okay, so from triangle ABD, we can get to know that there's a 90 degree symbol, or there's a right angle. Okay, so in that sense, we can look for the heights or the side AD. So let's go through by the Pythagoras theorem, and we say that square of the hypotenuse is equal to the sum of squares of the other two sides. So then it means 2 squared, this side, the longest side, 2 squared is equal to 1 squared, then let me call this side x plus x squared. Okay, so in this sense, this is 4 equals 1 plus x squared. And then x squared becomes 4 minus 1. So x squared is going to be 3. So it means x is equal to roots 3. That is taking square root of both sides. This is going to give us roots 3. Okay, root 3 units. Okay. Now, if this is root 3, then we can talk about the 60 and 30 degrees angles. Then after we'll look at the 45 degrees. Okay, so sine 60 degrees. Sine 60 degrees is equal to, sine is opposite over hypotenuse. So sine 60, this 60 faces the side. So that's going to be root 3 over 2. Root 3 over 2. That is opposite over hypotenuse. Then we can also talk of cos 60 degrees. And that is also, cos is adjacent over hypotenuse, which is 1 over 2. Then as well as the last one, tan 60 degrees. Okay. So tan is opposite over adjacent. So which is root 3 over 1. And that has always been root 3. Okay, so now we are done with 60 degrees. Now let's look at 30 degrees. So since we calculated for this side and had root 3, that is on this side. Okay, so sine 30 degrees. So 30, sine is opposite over hypotenuse. So 30 faces, the angle 30 degrees faces this side, BD, and BD measures 1 unit. So sine 30 is equal to 1 over 2. Then again, cos 30. Cos is adjacent over hypotenuse, which is root 3 over 2. Then tan 30 degrees. And tan is opposite over adjacent, which is 1 over root 3. So I said sine 30 degrees is equal to opposites, which is 1 over hypotenuse, that is 2. So 1 over 2. And then cos 30 is also, cos is adjacent over hypotenuse, and adjacent side is 3 units, root 3. And then the hypotenuse side is 2, so root 3 over 2. Then tan 30 is also, tan is 2, that is opposite over adjacent. So 1 over root 3. Okay. Now let's look at the 45 degrees. Now let's consider this right angle triangle on the board. So let me call this side A, B, and then C. Okay. So this is right angle in the sense that the symbol, right angle symbol is here. Okay. And this side AB measures 1 unit. BC also measures 1 unit. Now let's look for this side. So we can go by the Pythagoras theorem. So let me call this side A. So A squared is equal to 1 squared plus 1 squared. That is, the sum of squares of the other two sides is equal to the square of the hypotenuse. Okay, so A squared is equal to 1 plus 1. So A squared becomes 2, and then A becomes root 2. That is taking square root of both sides. Okay, now this side is root 2. So, and one thing more. We said this right angle triangle. So in the sense, in this sense, when you add all the angles, you should be getting 180 degrees. And this is 90. And since these two sides are equal, it means that this side is 45, then this side is also 45 degrees. So that this and this with this one will give you 180, will give us 180 degrees. Okay. Now let's look at sine 45 degrees. So the 45 can be this one or this one. So sine 45 degrees becomes, sine is opposite over hypotenuse. So it becomes 1 over root 2. And this can be rationalized to be root 2 over 2. Okay, so we can try this on a calculator. Then cos 45. Cos is adjacent over hypotenuse. So that is also, so making reference to this angle or this angle, we get the same thing. So that is 1 over root 2. And again, this is root 2 over 2. Okay. Then the last one, tan 45. Tan 45 is 1. Because tan 45 is opposite over adjacent. Or if this is what we are referring to, opposite over adjacent. So which is 1 over 1, and that is 1. Now let's look at this example. Find sine theta, cos theta, and tan theta if a line which makes an angle theta with the positive x direction of the x-axis passes through A, 5 and 12, B, -7, -24, C, -4, 3. Okay. Now here, what you are going to do is just to draw the Cartesian plane. Okay. Then you locate these points. So you draw for A, that of B, and then that of C, so that you'll be able to solve the question. Okay, now let's look at that. We are to put 5 and 12 on this Cartesian plane. So 5 is on the x-axis, so this is 5. Then -12 is also here. Okay, and they meet at this point. So I can draw a line from here to join the points. Okay, now the next thing, I am told to find sine theta, cos theta, and then tan theta of this. And please, the angle we are to concentrate, or the theta should form with the x-axis. Okay, so let me put theta here. Okay, so we are told to find cos theta, sine theta, and then tan theta. Okay, now from between this point to the 5 measures 5 units. Then between this point to this point is the same as from 0 to -12, and that is also 12 units. Okay, so I can redraw this small right angle triangle here. Okay, so let me draw it here. It's like this. Okay, there's not drawn to scale. Okay, so this is a 5 units and then 12. So we need this side before, and we can do this by the Pythagoras theorem. Let me put x on this side. Okay, let me change it so that it will not conflict with this one. So let me call this side a. So it means that our a squared is equal to 12 squared plus 5 squared. So a squared becomes 144 plus 25. And a squared becomes, the two give us 169. So a squared becomes, when you put square roots on both sides, a becomes 13 units. Okay, so it means this side is 13, a is 13 units. Okay, so now my sine theta becomes, so this is theta. Okay, so sine is opposite over hypotenuse, which is 12 over 13. Now, cos theta is also adjacent over hypotenuse, which is 5 over 13. Okay, let me put tan theta here. My board is very small, so tan theta becomes, let me add 2. So tan theta becomes, tan is opposite over adjacent, so which is 12 over 5. And you can say that this is 2 over 5. So 2 over 5. And this is the same as 2.4 units. So that is that. Okay, now let's look at the second question. So that is the B. So this is my Cartesian plane. And I've drawn it in this manner, in the sense that I'm not going to use the positive x and y side. Okay. So this point and this one will meet at this point. So let me draw a line from here, and then this is going to be my theta. Okay. Now from here to this point is 7 units. From this point to this point is also 24 units. Okay. So let me redraw this right angle triangle. We have it to be like this. So this is 24 and then 7. And then the angle is also here, theta. Now let me find the side. So let me call the side A. Now from Pythagoras theorem, a squared is equal to 7 squared plus 24 squared. So a squared becomes 49 plus 49, and then 24 squared is also 576. So the 2 will give us 625. Okay, so now we find A. So A is equal to, you put square roots on both sides, and A becomes 25. Okay, so this is 25 units. Now, since we know of this side, we can say that sine theta is equal to sine is, this is theta, opposite over hypotenuse. That is 24 over 25. Then cos theta. Cos theta is also, cos is adjacent over hypotenuse, 7 over 25. Then tan theta. Tan theta is also, tan is opposite over adjacent. So 24 over 7, which can be reduced to 3 whole number, 3 over 7. So 21 plus, yeah, that's the answer. Please try the third one, the C, on your own, and then put the answer on the comment section. I'll be expecting it. Thanks for watching. The name has always been Odum Maths. Bye.